In this video, I will explain what is happening when you want to calculate derivatives using limits, specifically for physics. So for physics, the most important thing is to define the position function that we will call s of t. This is the position function. So the position function is defined as s of t is equal to the negative value of the gravity divided by 2 times t at square plus the initial velocity times t plus the initial position. So you need these three elements here: the value of the gravity, the value for the initial position, the initial velocity, and the value for the initial position. So if you don't have the definition of the function, the first thing that you have to do is defining the function. I will say that in an example, let's draw here a building, and let's say that this building has 35 meters height. So there you have 35 meters height. You are here and you are throwing an object that will describe this parabolic trajectory here, and the object will reach a maximum position, and obviously this object has an initial velocity. I will say that the initial velocity is equal to, let's say 7 meters per second. So this is the initial position, S0. Now you have the element for the initial position, that is 35 meters. You have the value for the initial velocity, that is positive 7 meters per second. And now you need the value for the gravity. Gravity is a constant, and if we are working with meters, then the gravity has a magnitude of, or a vector of, negative 1.8 meters over second at square. So here you have the three values that you will need, and remember that the gravity is divided by 2, so you will use the negative 4.9 meters per second square constant. The thing is that the first step is defining the function. So you have all the elements to define the function. T will be your independent variable. This will be the independent variable, so it will stay as t during all the procedure, independent variable. In this example, the position function, s of t will be equal to the negative value of the gravity over 2, meaning negative 4.9 meters. Oh, sorry, you don't need the units here. Meters over second squared times t at square, plus the value of the initial velocity, 7 times t, variable t, plus the value of the initial position. And you have defined the position function. You will work with this position function later to determine the derivative and the second derivative of the function, that are the velocity and acceleration functions. But the most important thing first is to define the position function.